Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and leave a comment below. Today we're looking at Unit 6, Introduction to Quadratic Functions, Lesson 7, Building Quadratic Functions to Describe Situations, Part 3. Today's learning goal is to look at how to maximize revenue. We have 3 learning targets today. Keep these in mind as we go through practice problems, and at the end of the lesson we'll come back, look at them again, and make sure you've learned everything you needed to out of this lesson. Learning target number 1 says that you can choose a domain that makes sense in a revenue situation. Learning target number 2 says that you can model revenue with quadratic functions and graphs. And learning target number 3 says that you can relate the vertex of a graph and the zeros of a function to a revenue situation. Our first glossary term is quadratic function, a function where the output is given by a quadratic expression in the input. And remember, the quadratic expression is the x squared term. The next glossary term is vertex of a graph. The vertex of the graph of a quadratic function or of an absolute value function is the point where the graph changes from increasing to decreasing or vice versa. It is the highest or lowest point on the graph. And our last glossary term is zero of a function. A zero of a function is an input that yields an output of 0. In other words, if f of a equals 0, then a is a 0 of f. Another way to think about this is that if the function is equaling 0, then that means the y value is equal to 0. And if the y value is equal to 0, that means you're at an x-intercept. So when you're looking for the zeros of a function, you're looking for the x-intercepts. Our first practice problem says, based on past musical productions, a theater predicts selling 400 minus 8 times p tickets when each ticket is sold at p dollars. Number 1, complete the table to find out how many tickets the theater expects to sell and what revenues it expects to receive at the given ticket prices. So we can see that we have a table where the first column is the ticket price in dollars. The second column is the number of tickets sold, and the third column is the revenue in dollars. So if we want to fill out this middle column and find the number of tickets sold, what we're going to do is we're going to take the ticket price from the first column, all of these numbers here, and we're going to substitute them in for p in this initial equation that they gave us. So if we use 5, Then 8 times 5 is 40, and 400 minus 40 would be 360 tickets sold. If we use 10, then 8 times 10 is 80. 400 minus 80 is 320. Next, we have 15. 15 times 8 is 120. 400 minus 120 would be 280. Then we have $20 tickets. 8 times 20 is 160. 400 minus 160 is 240 tickets. If the ticket price is 30, then 8 times 30 is 240. 400 minus 240 is 160 tickets. If it's $45, then 8 times 45 is 360. So 400 minus 360 would be 40 tickets. Then we'll continue to do the same thing with these last two. If it was a $50 ticket price, then 8 times 50 is 400, and 400 minus 400 is 0. And if the ticket price was P, that would just be the equation itself, 400 minus 8 times P. So now we have found the number of tickets sold for each ticket price. Next, if we want to find the revenue in dollars, what we're going to need to do is multiply the price times the number of items that are sold. And that will equal the revenue. So 5 times 360 is $1,800 of revenue. $10 tickets times 320 tickets sold is going to be $3,200. $15 tickets times 280 tickets sold is going to be $4,200. $20 tickets times 240 tickets sold is going to be $4,800. $30 tickets times 160 tickets sold is going to be also $4,800. $45 tickets times 40 tickets sold is going to be $1,800. $50 tickets times 0 tickets sold would generate $0. And P dollar ticket price times 400 minus 8P number of tickets sold is going to be 400P minus 8P squared. And now what we can see is that we're going to have a quadratic expression to find us the revenue. Number 2. For what ticket prices will the theater earn no revenue? Explain how you know. Well, one of them we can see right here. We said that $50 ticket prices would result in no tickets being sold because the price is too high. The other price that this would happen at, there's two ways to get 0 as your answer when you're multiplying. In the first case we just pointed out, that's when the number of tickets that you sell is 0. The other way this could happen is if the price of the tickets was 0. So at $0, we earn no money for tickets given away. So if I'm going to multiply and I'm going to end up with 0 as an answer, then one of the numbers that I'm multiplying has to be 0. So in the context of this problem, either the ticket price has to be 0 or the number of tickets sold has to be 0. And number 3, at what ticket prices should the theater sell the tickets if it must earn at least $3,200 in revenue to break even? And that means to not lose money on the musical production. Explain how you know. Well, one of these we can see. Right up here, we said that when the ticket price was $10, they would earn $3,200 of revenue. Then if we keep coming down, we see the jump from $30 to $45, and we go from $4,800 of revenue down to $1,800 of revenue. So it is somewhere between here. If you notice, when we had $1,800 at the top, it was for $5 tickets. And when we went up $5, we got the $3,200. So I'm going to assume that I could do the same thing here. $45 tickets get me $1,800. So I'm going to change it by $5, and I'm going to see if that works. 400 minus 8 times 40 results in 400 minus 320, which is 80 tickets. So now if I took $40 and I multiplied that by the 80 tickets, that would in fact get me $3,200 of revenue. So my answer for number 3 is that ticket prices must be between $10 and $40 to earn at least $3,200 in revenue. So this is how we can use quadratic expressions to model a business cost like revenue. So if you plan ahead and you understand how many tickets you need to sell, at what price you need to sell them, you can make sure that you're not going to lose money if you're doing a business like this. If you have any questions about this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2 says a company sells running shoes. If the price of a pair of shoes in dollars is P, the company estimates that it will sell 50,000 minus 400 times P pairs of shoes. Write an expression that represents the revenue in dollars from selling running shoes if a pair of shoes is priced at P dollars. So, in order to answer this question, you need to understand what revenue is. And revenue is the number of items sold multiplied by the price. So this is the amount of money that you make before paying off any of the debt that you had to get in order to make the product. So this is money you made before adjusting for expenses, which would then end up giving you profit. So right now, we know that the number of items sold is going to be represented by this equation up here. And we know that the price is going to be represented by P. So what we can do is take P and multiply it by 50,000 minus 400 P. We take the P and we multiply it by 50,000, and that gives us 50,000 P. We take the P and we multiply it by negative 400 P, and we get minus 400 P squared. So this would be the quadratic expression that models the revenue that would be raised by selling these shoes at this price. So now we can take any price, substitute it in for P, and find out how much revenue they would make. And by doing that, we can figure out the best price to sell the most shoes and generate the most revenue before we would start losing sales because of the price being too high and the revenue coming back down. So if you have any questions about practice problem number 2 and how to set up a quadratic expression to represent revenue, please leave a comment below and I'll get back to you with any help that I can offer. Our last practice problem says the function f represents the revenue in dollars the school can expect to receive if it sells 220 minus 12x coffee mugs for x dollars each. Here is the graph of f. Select all the statements that describe this situation. So choice A says that at $2 per coffee mug, the revenue will be $196. Well, the price is the X value. So I want to come over to where the price is $2, and I want to go straight up until I hit the function. When I hit it, I'll look to the left, and I see that at $2, we expect $400 in revenue, not $196. So A is wrong. Choice B. The school expects to sell 160 mugs if the price is $5 each. That means we need to take the equation, substitute in the price, and see how many mugs they expect to get. So we have 220 minus 12 times 5. This becomes 220 minus 12 times 5 is 60. And 220 minus 60 is 160 mugs. That is what it says, so B is correct. Choice C. The school will lose money if it sells the mugs for more than $10 each. Well, if we look at $10 each, everything beyond here is still making money, at least revenue-wise. To know whether or not we were going to lose money, we would need to know how much the costs were. So for this one, we don't know the costs. So we don't know when they lose money. The line coming down does not mean they're losing money. It just means they're making less revenue. So they could make less revenue and still make profit. We just don't know because they don't tell us the profit. Choice D. The school will earn about $1,000 if it sells the mugs for $10 each. So again, we're going to look where the price is $10 each. We're going to go up until we hit the line. We'll look to the left, and we will make $1,000 revenue. So it depends on what they meant. The wording of this is not great. Will they earn $1,000 of revenue? Yes. Will they earn $1,000 of profit? No. But since we've been talking about revenue, I'm going to assume that is what they meant. And in that case, D would be correct. Choice E. The revenue will be more than $700 if the price is between $4 and $14. So we go to where it's $4. We go up until we hit the line. We look left, and it looks like it's right about $700. We go over to 14. We go up until we hit the line, and then we look left, and again, it looks like we're at $700. So everything up in here is going to be more than $700 of revenue as long as we're between $4 and $14. So E is correct. And choice F, the expected revenue will increase if the price per mug is greater than $10. Well, we said when we looked at $10, everything beyond that, we see the revenue going down. So actually, revenue is decreasing after $10. So F would be wrong. So if you have any questions about this practice problem, how to read a graph in relation to price and revenue, please leave a comment below and I'll get back to you with any help that I can offer. At this time, let's go back and take a look at the learning targets and ensure you've learned everything you need to be prepared moving into further lessons. Looking back at our learning targets for this lesson, number 1 said that you can choose a domain that makes sense in a revenue situation. And as we saw in the practice problem about selling the tickets to the theater, if we don't have a price on the tickets, then we don't make any revenue. So that would be the start of our domain. And as we increase the price, we see the revenue start to go up until it hits that optimal price at the vertex. And then it's going to come back down again because as the price continues to increase, fewer people are going to buy tickets. And eventually you hit a point where it's just too high and nobody buys. And your revenue is back to zero. And so your domain is going to be in between those two numbers. And you have to take into account not only your revenue, but what price point or how much revenue you need to hit in order to at least break even and not lose money. And then you really want to make your domain somewhere in between there if you're trying to make profit. Learning target number 2 said that you can model revenue with quadratic functions and graphs. So as you saw when we were filling out the table, revenue is the price of what you're selling times the number of items that you sell. So when you end up multiplying a variable as the price and then an expression representing the number of items that you can sell using that variable, you end up creating a quadratic expression. And so that quadratic expression or quadratic function can model the revenue. And we saw that when we were looking at the graphs and analyzing those, the quadratic function models it from a price of 0 giving you no revenue, raising up to a vertex, which is going to be your optimal mixture of a selling price and the maximum number of items, creating that maximum revenue. And then once you go past that tipping point, then your amount of items starts to come back down until you hit that price point where no one will buy it anymore. So we can see that it can be represented by both the quadratic functions and the graphs that go with it. And then the third learning target says that you can relate the vertex of a graph and the zeros of a function to a revenue situation. And that's what I've been describing here in the last two, is that your vertex is that optimal price point for selling where you will get the maximum revenue. Anything before it, and you're kind of cheating yourself out of some revenue because you're pricing your item too low. But anything beyond that, you start getting greedy, people start paying less and less and less. And so you actually end up losing revenue. So you're trying to find that sweet spot right in the middle that generates the highest revenue because it's the best selling point that results in the most items being sold with it so that you make the most money as far as revenue goes. And then your zeros are referring to those x-intercepts. So you've got one at the beginning that says if you don't charge any money, you're really just giving stuff away, so you're not making any revenue. And then the other one is that price point where you've put the price so high, nobody wants to buy it anymore. So again, you're back at zero revenue. So you need to make sure that you're understanding how the vertex and how those zeros relate to the revenue function. So hopefully you've picked up everything that you needed to know in this lesson. If you have any questions, please feel free to leave a comment below and I'll get back to you with any help that I can offer. Please give this channel a subscribe, give this video a thumbs up. You should see a video on the screen that YouTube thinks might help you out. And I look forward to seeing you in the next lesson.